morning, Algebra 2. How are you doing? Today we're going to look at something called an imaginary number. Everything you've dealt with in your math career so far has been using real numbers. Sometimes we solve a problem and the solution is all real numbers. So we look at the domain and range and it's all real numbers. Today we're going to look at actually something called an imaginary number. So we have been simplifying radicals. And you know how to do something called like square root of 9 is 3, square root of 4 is 2. And we even looked at one where square root of 12, and we broke that down to 4 times 3. And then took the square root of 4, which is 2, and then the 3 stays under. So you know how to simplify radicals. But then what if I gave you the square root of negative 9? Or the square root of negative 4? Or the square root of negative 12? Always before, what you've done with this is said no solution or no real solution, because you've been taught you can't take the square root of a negative. When we introduce this imaginary unit I, it allows us to simplify these negatives. This square root of this I represents the square root of negative 1. This is really important for you to remember. I is equal to the square root of negative 1, and I squared is negative 1. Because if we do the square root of negative 1 times the square root of negative 1, we get negative 1. Okay? The sole purpose of this symbol, the I, is to represent the square root of negative 1. You're familiar with a symbol in math, right? A symbol in math. If I show you this symbol, you know that is 3.1415 and so on, right? Or because it's a symbol and you know what that symbol represents. Today we're learning a new symbol, and that new symbol is I, and it is the square root of negative 1. So when we had that square root of negative 9, that means negative 1 times 9. Square root of 9 is 3. The square root of negative 1 is the I. If we had the square root of 4, negative 4, that would be, we need our little plus or minus, 2I. The square root of 12, negative 12, would be the square root of 4 times 3 times negative 1. So it would be 2I times the square root of 3. So that's how we simplify with a negative under the square root. So let's look at how do you write the square root of negative 18 by using the imaginary unit I. So I can take this. What's the biggest square that divides into negative 18? When I say the biggest square, I'm talking about one squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 36. Those kind of numbers, those are perfect squares. Okay, the biggest perfect square that divides into 18 is 9. 9 times 2, and then we'll put in our negative 1 to get rid of that negative sign. Square root of 9 is 3. The 2 stays under. Square root of negative 1 is the I. Plus or minus 3I square root of 2. And that's how we simplify using that I to represent the square root of negative 1. Okay? So let's listen to Savas Realize tell you that. I've got to do this. Now.
In this problem, you will simplify a number using the imaginary unit I. How do you write the square root of negative 18 by using the imaginary unit I? In this problem, you will
Here's the solution. Okay, and you'll see they did what I did. Take this negative 1 times 18, and they simplify this as 9 times 2. Square root of 9 is 3. There's the 2. There's your 3I square root of 2. And they didn't put the plus or minus in there, so that'll work. Okay. Next. How do you write the number square root of negative 12 by using the imaginary unit I? So we're going to take 12 is 4 times 3. Square root of 4 is 2. Then the square root of negative 1 is represented by I. And the 3 stays under. Okay. So the simplify radical process is the same. The negative, basically this negative turns into this I. Because this square root of negative 1 is represented by the I. Remember, two very important things. Two very important things. I is equal to the square root of negative 1. I squared is negative 1. Those things need to become automatic. As automatic as you know that pi is 3.1415 and so on, you need to know that I is the square root of negative 1 and I squared is negative 1. Right. Okay, now that we know how to simplify with that, we're going to look at how do we work with these complex numbers. Complex number has a real part and an imaginary part. Excuse me. And we're going to look at adding and subtracting complex numbers. Okay, and this says, what is the sum or difference? When you add and subtract with complex numbers, a real part and imaginary part, the 4 is the real part, negative 4 is the real part, 3i, that's the imaginary part. The part with the I is the imaginary part. It's similar to combining like terms. You can only add real part and real part, or subtract real part and real part, and you can only add or subtract imaginary part with imaginary part. So this 4 plus negative 4. What's 4 plus negative 4? That's going to be 0. And then negative 3i plus positive 3i is 0. It says use the commutative and associative. Okay, so they actually changed the order and rearranged it. You can do that if you want, or you can just know and understand that the real parts, the parts without the I, can be added or subtracted, and the parts with the I can be added or subtracted. So this 4 plus negative 4 is 0. Negative 3i plus positive 3i is 0. And why they used an example that ended in 0, I don't know. But it's like adding like terms. Add the parts without the I, add the parts with the I, or subtract the parts without the I, subtract the parts with the I. Let's see if we got another example. It doesn't like me to draw and then change things. Okay. What is the sum or difference? Right. So we have 5 minus 3i minus, be careful of the minus, negative 2 plus 4i. Just like with like terms. This 5 minus negative 2. That's my webcam box. So I don't forget. Oh no, this doesn't want to go there. Never mind. Okay, so I have 5 minus negative 2, which is 7. And then I have negative 3i minus 4i. Negative 3 minus 4 equals negative 7. So my answer is 7 minus 7i. You cannot combine one with an I and one without an I. Excuse me. All right. Here we go. Here's 5 minus negative 2, which is 5 plus 2. That's 7. You can see they did the same thing we did. Okay. One more. What is the sum? Again, we're going to add the real parts and add the imaginary parts. Okay. So we have 7 plus negative 3, which is 4. Negative 2i plus I, negative 1. So 4 minus I. Let's look at our answer choices. There it is. I say B. What do you say? You agree? There we go. B it is. That's adding and subtracting. It's just adding the parts without the I, adding. It's just like adding like terms. It's really pretty easy. All right. Next we have multiplying. Don't worry, we're not going to go through all of those today. When you multiply, it's again similar to what you already know with multiplying. They don't have to be the same parts, or they don't have to be like terms to multiply. Let's see, what if you had what if this were 3x times negative 5 plus 2x? You would multiply this, and you would multiply this. Okay? And you'd be done. But this is not x's, this is i's, and it works the same way. So 3i times negative 5 is negative 15i, and 3i times 2i is 6i squared. Oh, you remember our very important things? What were our very important things? Very important things are I equals square root of negative 1. I squared is negative 1. There's I squared. Ms. Riddell said the very important thing is that I squared is equal to negative 1. So what I have here is negative 15i plus 6 times negative 1. There we go. That's it. We can't go any further because we can't add or subtract, one with an I and one without. So basically, when you multiply something by I squared, it's multiplying it by negative 1, so it changes the sign. Right? I told you this was easy. You think this is easy? I hope so. Okay. In case you don't believe me, there it is. Distributive property. I squared is equal to negative 1. Simplify. Boom. There it is. Okay. Let's try another one. What is the product? Remember, we can use box method, we can use FOIL, we can use distributive property. Really, all of those are the same thing. We're multiplying. Okay, so what are we multiplying first? 4 times negative 1. 4 times negative 2i. 3 times negative 1. I'm sorry, 3i times negative 1. And 3i times negative 2i. Now, what can we combine? This, what is a very important thing? What's this very important thing? I squared is negative 1, which makes that positive 6. What's negative 8i minus 3i? It's negative 11i. And then have negative 4. What else can we combine? Negative 4 plus 6 is 2. And standard mathematical form is to write the real part first and the imaginary part first. A plus bi. Okay. In other words, you put the 2 first and the 11i next. Okay, what do? We distributed to do the multiplication. And we simplified, changing the I squared to negative 1, combining like terms. What is the product? Product means multiply. Again, you could do this with box method. Well, -6 times -6 is 36. -6 times -I is positive 6I. Positive I times -6 is -6I. And positive I times -I is -I squared. Ooh, I squared, that's a very important thing. I squared is -1. So that becomes positive 1. 6I, -6I, what happens to those? 6I minus 6I is 0, so those cancel out. 36 plus 1 is 37. It's okay for your answer to have just the real part or just the imaginary part. Time to wake up. Your answer can have just the real part or just the imaginary part, or it can have both. Okay? Questions? All right. What is the product? 7I times 3I. This is just like if you were multiplying 7x times 3x. You multiply the 7 and the 3. Excuse me. 7 times 3 is 21. I times I is I squared. Oh, I squared. That's a very important thing. What's I squared? I squared is -1. So this is 21 times -1, which is -21. So what have we done? We've done simplifying using the I as you know, that's our very important thing. Simplify using I as the square root of -1. And lose my train of thought. What have we done? We've simplified using I as the square root of -1. We've added, understanding that that's like adding or subtracting like terms. And then we have multiplied, remembering that I squared is -1, and that changes signs. You have an assignment today. It is Savas Realized 5-9. And it is the same thing. Simplifying the complex numbers. I think there may be one on there. Let me see something just a minute. Mute this guy. Yeah. Okay. So how does this I come into play when you have a quadratic equation? Because we're going to do more of this tomorrow, but I do think there might be one on your realized assignment. 2x squared minus 3x plus 5 equals 0. All right. So I'm going to use quadratic formula. And I have a is 2, b is -3, c is 5. I'm going to find the discriminant first, which is our b squared minus 4ac. This is -3. b squared minus 4 times a times c. This is 9. Minus 4 times 2 is 8 times 5 is 40. So 49 minus 40 is 31, -31. Do you remember the day we talked about the discriminant and what the discriminant tells us about the solutions? And we said that if the discriminant was negative, we have two complex solutions. This is where we get into that with this with the I, because where does that discriminant go when we plug into the formula? Remember, we have x equals negative b plus or minus the square root b squared minus 4ac all over 2a. This is negative. How are we going to simplify that? So we have, this makes positive 3 plus or minus I times the square root of 31. We can't simplify the square root of 31. It's not a perfect square. No squares divide into it. We pull out that negative as the I, because that is really 31 times -1, right? So we pull out the I. On the bottom, we have 2 times 2 is 4. There are 2 complex solutions. Okay. So that's where this I part comes in, is where if you're solving with quadratic equation and your discriminant is negative, you're going to simplify that using the I. I think there's one like that on your side. Okay, you have SAVAS 5-9, and tomorrow we'll look a little bit more at complex numbers. You guys are doing an awesome job. Enjoy your day.